Hello everyone. Hi guys. So we are introducing OpenVoice, a versatile instance voice cloning approach that records only short audio clip from the reference speaker to replicate the voice and generate speech in multiple languages. So this model, versatile instance voice cloning, has two aspects: flexible voice style control and zero-shot cross-lingual voice cloning. So what is flexible voice style control? So you can control the emotions and various different things like rhythm, pauses, intonation. And the second aspect is the zero-shot cross-lingual voice cloning. So what does it mean? So like you can make different lingual voices, like you can create Korean, you can create Russian, you can create like different voice just by using this OpenVoice versatile instance voice cloning. So it's a very useful tool. So voice cloning is text to speech synthesis. Like there is a TTS model that can clone any voice of any speaker given a short audience sample without adding training on the reference speaker. So the problem with the traditional model is that you need a lot amount of data to train your model. Can you go to the next slide? So we have divided this into three parts. I will be going with overview, then Mustaba, then Kranti with final statement. So can you go to next statement? Next slide. So my part is overview. Can you go to next slide? So as we talk about this, how this model, what are the some specs, like how does it work? So why do we need this? Like, why do we need this model? So what this model will have to do? So like with the previous model, like Wally and XTSS, they can clone like tone color, but they were not that much useful and flexible to manipulate important style parameters, such that if you want to make like voice with different emotions, with different accent rhythms, they cannot perform this. And the one drawback is that you have to use a lot of computational to train them. So they're relatively more expensive. And so that's the thing in AI, that expense matters. So you need a lot of data set to train your model. So can you go to next slide? So as I talk about this model, so it has two important aspects, like flexible and it's cross-lingual. Like you could produce any different kind of language if you want Korean, etc. And also you can use different emotions. So how does this model work? So what is the architecture? So architectures like that, you have reference voice, like so to say you want to create a voice, and you have the speaker Elon Musk, like you want to speak of Elon Musk. So you will give some voice, like some chunk of voice, and you will give as a reference. So it will you have three things. You will give a reference voice, then you have text, and you will describe what accent you want. So it will be this is our architecture. It will encode the reference speaker voice, then combine with textual context, what accent do they want. So it will combine these things and it will produce your desired result. So this is the basic architecture of OpenVoice model. Can you go to next slide? So these are the things like I've told you. So they are actually they prefer like they have different advantages. They can produce multiple language. They can produce different accent, so that you have more control over your voice generation. So this is worth the advantage of using OpenVoice. Can you go to next slide? So from now on, I'm leaving to Mustafa. Mustafa, can you continue from here? Thanks.
Thank you, Abdullah, for presenting the first part. So in this part, we're gonna go over some demos to show how this app works and just show you a couple of like presentations to see it actually works real time. And it's also a note I wanted to note that this app is currently open, open source, so it's free to access for now. So let's go to the next slide. So before we show the demos, there are a couple of remarks I wanted to mention. Abdullah just described the structure of the OpenVoice. Just wanted to add that the novelty of this OpenVoice app is actually decoupling the two frameworks that they needed to extract the style and tone and everything from the reference speaker voice. So they decoupled the part that extract the style and language control from the part that they clone the tone color. So this is their main contribution. So they haven't invented like anything new, but their contribution is that they decoupled these two parts, and it actually made the implementation much easier. They don't need like tremendous amount of data to process the voices. So another point is that they have used the VITS, the variational inference with adversarial learning for end-to-end text-to-speech as their base TTS model, as their base speaker text-to-speech model. And the tone color converter is, again, it's not something new that they invented. It's an encoder-decoder structure with an invertible normalizing flow in the middle. Abdullah, I guess he explained it very well. And the last point is that in OpenVoice, as long as we have one single speaker TDS who speaks fluently, then the cloned voice will be also fluent. So this is noted. So let's go to the next slide. I'll show you some like demos how it works, and you can see.
OpenVoice. Instantly call any voice to generate speech in any style and any language. We are conflating a lot of things with the word intelligence. Ethical concerns around AI societal impact.
3, 2, 1. Ethical concerns surround AI societal impact.
Wanders and watches with eager ears. The aroma of freshly baked bread filled the kitchen. The aroma of freshly baked bread filled the kitchen. The aroma of freshly baked bread filled the kitchen.
We are conflating a lot of things with the word intelligence.
早点休息吧 Rest early. Hek jasuli kudasai. Lopus tuetu. Descansa temprano. Отдыхай рано. Идите шьё.
OpenVoice. Clone any voice in an instant. Take control of a style across any language.
Okay, so yeah, this demo showed that we can have like different from the reference speaker that we can extract like different tones and intonations and different languages as well. So let's go to the next slide. So we have also other demos. Let me. Okay, so the first one, so this is a demo that actually. So we will need like a reference speaker voice, and then we want to generate like a voice from this text. This is a demo of OpenVoice. Click start to clone your voice. So if I do start, so the reference speaker, as you heard, it's Elon Musk.
There's the scientific method, which I very much believe in, where something is true to the degree that it is testably so.
So we have like 29 seconds from this reference speaker, and then we want to generate, for example, this text to convert to audio. We can use different emotions. As you see, we have like default, friendly, and like other emotions as well. Let's put it on default. So let's go ahead and then we click generate.
My Shell is the first platform to combine AI and Web3.
Okay, yeah, and this one is for this text.
This is a demo of OpenVoice. Click start to clone your voice.
So this was actually generated from my voice. So if I go to start, I have recorded a couple of seconds from my voice. This is a ref speaker file. I can upload it here and then generate.
My Shell is the first platform to combine AI and Web3.
Yeah, so this was generated from my voice, and again, this was generated from my voice again. So let's go to another demo. Again, this is the reference speaker file from Elon Musk, and then we want to generate the result that actually reads this text. So this is
this is the scientific method, which I very much.
This is the same voice from Elon Musk, and
He hoped there would be stew for dinner, turnips and carrots and bruised potatoes and fat mutton pieces to be ladled out in thick, peppered, flour-fattened sauce.
And we can also change it to different styles. Like, for example, let's do terrified.
He hoped there would be stew for dinner.
Sorry. Yeah, sorry, I guess I have to first log in. So I guess the third demo also shows this as well. Let's go to the third demo we have. And so this is the open source app. We can use it for free. So this is the same text, and the reference speaker again is Elon Musk. Let's put like terrified style, and then I agree and send. A couple of
He
seconds.
hoped there would be stew for dinner, turnips and carrots and bruised potatoes and fat mutton pieces to be ladled out in thick, peppered flour-fattened sauce.
This was terrified, for example. We can also put as angry and send.
He hoped there would be stew for dinner, turnips and carrots and bruised potatoes and fat mutton pieces to be ladled out in thick, peppered flour-fattened sauce.
Yeah, so you see that we can just like play with it. So we have different styles, and we can also add another add a sample voice from another language, and also it takes care of it. So let's go back to this. So the third part is I guess Kranti is going to take over. Kranti, please.
Yes, thank you, Siraji. And we are going to see the final thing, what we have learned from the presentation, some conclusions. Next slide, please. So in this slide, we can see just like what we have discussed till now. We can see the flexible voice control and the zero-shot cross-lingual voice cloning that we have that the OpenVoice can do. So we can see in the flexible voice control, it shows the amount of variations in the emotions that we specify. And in the zero-shot cross-lingual voice cloning, we can see the languages that is differing in the by giving the reference pic. The next slide, please. So what the OpenVoice model contains a decoupled structure with a TTS model, text-to-speech model, and tone color converter for the working of. So the TTS model works in a way that we have to specify the parameters and the target language that we are willing to generate, and the tone color converter would match the fingerprint of our reference speaker to the generated voice given by the TTS model. And further, the OpenVoice model is a near zero-shot cross-lingual voice cloning because it still requires a base speaker for a zero-shot voice cloning. And OpenVoice model doesn't have any autoregressive components linked in it. So it generates all the speech at once. So it is considerably faster than the previous models that came before it, just like Wall-E and XGTS models. The next slide, please. And the training data set that we have seen, OpenVoice is near zero-shot voice cloning. That means that it doesn't require massive training data sets to be trained on it. And we are training the TTS model and the tone color converter model separately, and we are coupling them. So for the TTS model, we are using the 30K sentences in total, and the average sentence length is 7 seconds. And we are having variations in the dataset too, with 2 English accents and 1 Chinese and Japanese speakers. And for the tone color converter, we are using a different dataset of around 300K audio samples. And we have the variations also too in it with English, Chinese, and Japanese. The next slide, please. And coming to the pros of the OpenVoice model, it is actually very fast, and also it gives us the ability to manipulate the styles and emotion. That means we can add emotion, accents, and the target language ourselves. So it gives us some control over what we want to generate, and it is also very fast. And coming to the cons of the model, the approach of the model is quite different from the models that came before it. Like if the evaluation metrics used for OpenVoice might be different from the metrics for the other models. Just like if you are using intelligible and meaningful sentences, or and it differs from the models that we are. It differs from the evaluation metrics that we are currently using. It might be confused for different models, and it is a matter of concern that it is how ethical it is to generate voices, and how can other people be fooled if using this model. The next slide, please. And the links of the official model that from the MyShell AI and the official research paper. That's it. Thank you.
Yep. Thank you, Kranti. So any questions if anybody had? Okay. So if there are no questions, so these are the links to the paper, and also this is, I guess, the link to the open source free OpenVoice app. Yeah, you can take a look. Yep. Yeah. So I guess if there are no